Yeah, thanks a lot for the nice introduction. I'm very excited to present a very important project for us today in collaboration with MI for People, who initiated the project in the beginning. And since we're on a data festival here, it would be just the best option to start with numbers and statistics. So did you actually know that only 10% of individuals who need addiction treatment also receive it, or that 47% of patients undergoing mandatory substance use treatment in Germany did not successfully complete their treatment, which is a huge number actually. In addition, when we also check worldwide, or especially such statistics are made in America, we can also see that around 60% of patients stop within the first month, and even 80% within the first year. The good thing is there is hope, because there is also some very recent statistic about 20% of AI-driven predictive analytics and personalized treatment approaches can help to reduce such dropout rates. And this is actually where our project comes into play. And we were thinking about how can we actually support therapists with such AI-driven solutions. And I mean, there are so many use cases you can dig into. But first of all, before I show you our technical journey, or also our project journey, I would like to introduce ourselves, who we are, and how it actually came to the collaboration. So 51 is actually an IT consulting company, and we do end-to-end analytics like many consulting companies, so from data strategy to cloud architecture to data science. But I think the most important is that we also want to support projects with impact, especially because we have background in the healthcare, in pharma, and projects that deal with sensible data. We wanted to support MI for People. And we are convinced that AI can be used for data-driven decision support, also in clinics and the public sector. And there's where MI for People came in, who is supporting machine intelligence in healthcare and environment and inclusion, who is building a whole network for volunteer-driven structures so that it is possible to actually form such projects, because of course there's not as much money. Money is more in industry. And indeed, we met here 1 year ago at the Data Festival, so thanks to the organization. And we directly started collaborating. Of course, this was volunteer-based, and I'm super happy that within 1 year we managed to build a solution with our team, with whole collaboration, that I now want to go more into detail. How did we start it? So our journey began with a 6-week research phase at a rehabilitation clinic to identify different use cases where we can digitalize, where we can automate in, first of all, one clinic. Later there were also further clinics added. And there were many applications actually, because, you know, public sector, sometimes a bit difficult. Also in the clinic, you have just a different focus. Everything on the patient, people are working so much. There's not that much focus into IT, I would say, as far as I experienced it. So there are options like maybe we can help for filling proposals, maybe personalized medicine. There's a lot of research going on. And one use case stood behind, that was the high dropout rates I showed you in the beginning. and that there was no data-driven solution available. So we defined the different challenges and the specific goal that we would like to improve this therapy outcome with AI to support especially the therapists and guarantee that you can help the patients to finish their treatment. So in the beginning it was very important that we define, okay, what exactly do we want to predict, what is realistic, and we needed to differentiate between different outcomes. So do we have a regular end of the therapy? Do we have a discontinuation by the patient? This I will call dropout in the next slide. Or do we have an end by the clinic, which would be a disciplinary discontinuation? So of course it was still a bit challenging in the beginning to receive the data, to make the first modeling, to prepare the data, but I will come to the technical part in a minute. And our vision in the end would be that, of course, this is implemented in the clinic and that we get this feedback validation loops to learn from our solution, that we have a dashboard for personalized interventions in case we can already see quite early, okay, maybe this patient could be a person who will drop out early, and now we can maybe help in different ways, and to define also the strategy behind it. Now, I would like to show you more general how we would approach such a problem and then go into the different steps of what exactly we were using. And maybe for some of you this is totally obvious, but I still want to repeat it because it's so important that in the beginning, for example, we have exploratory data analysis. Maybe it also changed a bit with all these Gen AI use cases because you have a different approach in the beginning. But it's important that you understand the data, that you have knowledge about the statistics, that you can have some first anomaly detection or clustering to really understand in which direction you can go and where would also be the value. Then, of course, for patient data, you have so many different variables. And it's super important that you filter them, that you go into conversation with the physicians to understand which features are actually the most important and could help me to define my goal. And also to split the data and training test and validation set to define the specific metrics in the end so that you can trust the model. The model selection and development, so the heart of the whole process, is very important because besides different large language models that come in, we still have a lot of traditional machine learning. We have a lot of advanced deep learning approaches that can be used for very specific use cases, and they are still very important. They are also still developed, further developed, and there is also news coming in, however, maybe not that suitable for everyone like it is with the large language models, but still very important. And here we need to define relevant parameters, also understand how the model actually can be used. And of course, we want to tune the model. It's important that we define our validation strategy, especially of such sensitive data, so that the physicians can also trust the model. And in the end, of course, we want to integrate the whole solution. We want to detect model drifts, maybe automate the whole pipeline so that we can guarantee optimization if there's maybe some change in the data itself. And all of this we would like to establish in AWS, since we have a lot of experience there. Of course, we are in the beginning of the journey. It is very difficult to get such a solution in the clinics, but I will give you some more detail later on. So what was actually available in the beginning? We had data from 3,600 patients between 2017 and 2023 across 3 different clinics. And we need to find the outcome, what kind of therapy end we had. We had the diagnosis and therapy in general, so ICD-10 codes, clinical history, which substance was used, which is a huge impact on the outcome. And most importantly, because it's such a critical field, the demographics has a huge impact. So the personal and the social background. And we need to be sure that we continuously evaluate the ethics, data protection, and be also sure that we don't discriminate anyone with such decision support. So indeed, when we check the average of the 3 clinics and the probability of such an event, so the regular and the dropout and the disciplinary, we can already define critical dropout phase between week 2. Is this working? No, okay. Between week 2 and week 14. And we could already see that 22% of these cases result in early discontinuation by the patient or the clinic. And we could already detect, okay, we have an average treatment duration between 6 and 14 weeks. So maybe here we should implement some monitoring. And actually the longest part in this development was the model selection, also to find a model that can really predict such an outcome and optimize it in that way. When we check different models, we always look at different criteria like the performance, so how good actually our model predicts compared to the observed data that is already available. The robustness, we need to rely on the model itself. Is it general? Is it good in generalizability? When I get a new data set, is the outcome still comparable? I need to be able to explain the model, because also in such critical fields, maybe physicians also don't have that much time. I would like to convince them that this could really be a benefit. And we also, because costs are everywhere important, need to take care that the computational resources are efficient enough. So we decided to check, or we found 3 suitable models that we wanted to compare with each other. And first of all, usually we check that we have more simple one, or they're quite diverse, so that we can really have a good message in the end. And we, for example, check the logistic regression model. Of course, easy to explain, more statistical, but we would have problems for the robustness. So also when we increase the data set, or it would get more complex, you would get more features, maybe we will come into problems. Then we checked the competing risk random survival forest, which is actually an ensemble model. So basically it is a comparison between different random or multiple decision trees. And it can already deal with quite complex data like we had in this case. It is a bit less interpretable compared to the logistic regression, but you can still actually quite good explain such decision trees. There are many options. And since we have very advanced techniques also available, we wanted to check a deep learning approach. In this case, the deep hit. This is specific for survival analysis, and it is possible that also it can deal with very huge data sets. To learn the dynamics, you can increase the features, you learn basically on your data. You don't have maybe a statistical extrapolation or something, but you really have, you are also dependent on your data, of course. The data must be in a good structure, and data quality is even more important here. but it's a bit more difficult to explain. But this shouldn't be the problem in the end. We will find a way to explain it. And we found it. I will show you in a minute. So actually we decided indeed to go for the deep learning approach because we want to scale up this product. We want to get even more collaborations, even more clinics, even more data, and then this would be the best way. And also in terms of metrics, it was a bit better for this current data set. The others still performed actually quite good, so it's also possible with simple data sets, but for the strategy we have in mind, where we want to go, we need the complexity as well. So let's, the interesting part, the explainability, and what will the therapists, the people in the clinics actually see on their dashboard. So the thing is, when I do explainable AI, for example, I can have feature importances, sharp values. There are many different techniques, and this is also sharp-based. And usually you would have a base value, which is actually the model's expected output before considering individual features. And then you could easily describe it. You would have on the dashboard the whole information about which kind of risk factors these patients would have. That would, in this case, increase the likelihood of an event. We focus on the dropout by the patient because this is the one that we can influence or maybe intervene by the therapist. So for this specific patient, we would have risk factors like young age and substance use. He was not involved in a self-help group or limited institutional support, high addiction severity, financial burden, also the education plays a huge role. And unfortunately for this patient, we only had very weak protective factors on the other side, like only the institutional setting and a year of admission, which leads to the prediction of a 32% probability that this patient will actually drop. And in this case, within the first 16 weeks. Indeed, this patient dropped. And the idea is that the therapist could then add the new data. It knows exactly that the model is performing good for this kind of data, so I will bring it in the specific structure, but it's very nice actually for this kind of clinics because they already have everything in the same structure. Some of them have the same system already, so you can easily implement it in several clinics. And now I showed you the prediction for 16 weeks, but it's also possible to check every week or actually at any time point to understand how the risk factors evolve over time. So here you can see the feature influence, also sharp-based, which evolved over the time of, I think it was 36 weeks. And what you can see already is that when you check the dropout by the patient, that the risk factors emerging as early as week 4. And this results in the conclusion that we can intervene. We can intervene very early, and we have to define different strategies, what we can do, or maybe we can then just be more protective with this kind of patients. So, of course, we're still in the clinic. It's very important that everything is handled quite securely, so the data platform is also very important. And right now, we are not at a stage to, this is still a research project, so we have a vision in mind, but so far we just have we were working on premise, but we were already transferring the data on AWS, and this is still in progress, it's not finished yet. But the idea is that we have several clinics and they could transfer, for example, we VPN and secure and encrypted protocols. They can transfer their data, and then it's anonymized or standardized, or some data engineering pipeline is behind it. It's also possible with several services of AWS that we have real-time data coming in, which would also be the idea that the physician can react directly, and then the data is only saved after the whole process within the data lake, so that we can get sure that only the physician has actually the access, or the people who are allowed in the clinic have access to the patient data and no one else. So yeah, as I mentioned, we are still on a journey, but I'm still very happy what we managed within 1 year of volunteer work, because we are all, of course, still having our main jobs, but we wanted to contribute to such an interesting project. And there are still a lot of tasks that we aim to follow, and one of it is, of course, that we have even more collaborations, that we expand the data quality and diversity to improve this generalizability, also to prove that our model is working for other clinics and not only for this free. We want to integrate it in the systems directly and not only by an extra dashboard, because you need to get the tool to the people so that they really get into use, even though it's more exploratory and more a support. It should never exchange any person or any decision, but just support to be fast and also to have this intervention. We are also thinking about approaching counseling centers, and here it would be important that we adjust the model, adjust the features. Maybe we have other needs for non-clinical settings, and it's important that, and this would be actually, I mean, this data is already available. We have all the patient information available, so maybe the next step would even be that we go into this personalized recommendations in terms of therapy as well. This is of course more critical, because then we are also talking about medical devices. There's a lot of regulatory behind it. We need to be very careful in this field. But still it's very important, and we need to start somewhere, even if it would be a journey of years. And in the end, we want to have this exchange of the collaborating clinics with the counseling centers, and get us into a phase where we really have a good monitoring, a good optimized system. Because, I mean, we have worked with healthcare startups, we've worked with different healthcare products, and we would like to share this experience as well to help become or getting a better healthcare system as well. And by this, I would like to thank you for your attention. I'm very happy to discuss with you maybe some more details, and I would like to thank the whole team behind it, and the possibility to be part of such a great project, thanks to MI for People as well.
So many thanks, Linda, for this great presentation and also for contributing to get better healthcare.